Welcome back to the deep dive. If you're like a lot of the learners who come to us, you need the fast track to understanding how these really sophisticated AI systems are built. Like the ones that actually go out and do things, not just talk about them. We're sort of moving past simple chatbots here.
We really are. We're getting into true agentic automation.
Yeah.
And our mission today is, it's pretty technical, but it's vital. We're breaking down the architecture. We've got this blueprint, an 8-layered tech stack.
The backbone.
The backbone, exactly. It's a deep dive into the engineering decisions that make all this seamless automation actually possible.
Okay, let's unpack this. So we're going to walk step by step through the functional anatomy of the agent.
Right.
And we're starting right where any process begins, getting the information in, layer one. The input layer.
Yes.
What immediately jumps out from the sources is just the sheer variety of the entry points.
The diversity here really tells you everything about the system's intent. It's Tally, it's Slack bots, it's Zapier webhooks.
So you're saying you can't just force a user into one chat window?
You can't. If you're building an agent for automation, you have to meet people where they already work. So Tally handles structured data, Slack does the real-time commands.
And Zapier webhooks kind of connected to everything else.
They're the crucial entry points from, thousands of other apps.
And it's not just about user queries, right? I mean, for a system like this, it needs a constant stream of external data.
Precisely. And that's why the sources emphasize these REST API calls right within this first layer. The ability to pull data from, say, a CRM system or a financial database is fundamental.
So if your agent needs to automate a marketing workflow,
it needs to grab conversion rates via an API call before it can even think about making a plan. This whole input layer is a really sophisticated funnel.
Okay, so that robust input, that leads us directly into layer two. This is the system's, intellectual core.
The foundation modals layer, yeah.
If layer one is the ear, this is the brain that interprets what it hears.
This is where the heavy lifting happens. Interpretation, parsing, figuring out the user's intent. And here's where it gets really interesting.
Go on.
To handle these complex instructions, the system has to leverage, the top-tier foundational models. The sources specifically mention powerful ones like GPT-4 and Claude 3.
I have a question on that. We see GPT-4, we see Claude 3 mentioned all the time in chatbot contexts. Why are these specific huge models necessary here?
Because the task is totally different. In a chatbot, the model's job is just to generate coherent text.
To talk back to you.
Right. In an agentic system, the model's job is to accurately interpret natural language into a structured multi-step plan. It needs incredible reasoning, access to general knowledge, and, most importantly, the ability to pick the right tools for the job.
That planning and tool selection piece, that requires a lot more horsepower.
It demands the processing power and scale of the biggest models we have.
And building on that complexity, the material also highlights this move toward multimodal capability.
Yeah.
Specifically, it calls out OpenAI Whisper. So why is handling voice and text such a big deal for automation potential?
Because automation in the real world is messy. It's not linear.
Okay.
Think about a manager leaving a quick voice note for their team. If the agent needs to create project tasks from that, it first needs Whisper to accurately transcribe it.
I see. So it lets the agent engage with the real world, where data is in voice notes, images, documents.
Not just in clean little text boxes, exactly. Yeah. And that capability directly increases the number of tasks the agent can handle on its own.
Got it. So we've received the input, the core models have interpreted the user's intent. Now what? We move to layer 3, the agent's framework layer.
The nervous system.
Yeah, this is where the actual planning happens.
This is the critical layer. It's where that single high-level goal gets broken down into a series of actionable steps. The system has to decide, okay, to get to goal X, first I do Y, then Z.
And to manage that, it uses specific frameworks. I'm seeing LangChain, AutoGPT, and Agent Graph.
That's right.
We hear LangChain a lot. But what's the difference here between something like AutoGPT and Agent Graph?
They serve slightly different planning roles. LangChain is like the Swiss Army knife for stringing these things together.
Okay.
AutoGPT is for highly autonomous execution. It sort of evaluates its own results and decides the next step, often without a human in the loop.
Which sounds ambitious.
It is. Agent Graph, on the other hand, is more about managing and visualizing the workflow. It's like the AI's flowchart manager.
I see. And a plan that takes time to execute.
Yeah.
Well, the agent needs to remember what it's doing. Context retention.
Right. It can't forget steps 1 through 5 while it's working on step 6.
So what are the specific memory tools mentioned for that?
It's a pretty sophisticated blend. You have Google Sheets for simple, structured stuff. You have LangChain's own memory module for short-term conversational context. And then critically, you have Pinecone.
Pinecone. Okay, that's the so what moment, isn't it? Why is investing in a specialized memory solution like Pinecone, a vector database, so crucial? Why not just rely on GPT-4 to remember everything?
Because even a massive model like GPT-4 has a finite context window, a hard limit on what it can hold at once.
And for a long-running task, that's not enough.
Not even close. For automating, say, a quarterly report over several weeks, you need persistent, scalable memory. Pinecone lets the system store embeddings vector representations of past interactions and documents.
So instead of cramming everything back into the prompt,
It just queries Pinecone, grabs only the most relevant bits, and inserts those. It's an architectural choice that gives you massive gains in speed and continuity. Without it, long-term agency is it's impossible.
that makes perfect sense. Separating memory from processing is key for scale. Okay, so the agent has a plan, it has a memory, time to act. Layer 4.
The tools integration layer.
This is where it connects to the outside world to actually do stuff.
This layer is all about establishing the capability, the technical handshake. It gives the agent hands to interact with the digital world.
Then the sources give clear examples. We see Replit for running code and Zapier for automating actions.
Exactly. Zapier, for instance, has this huge catalog of pre-built integrations. So the agent framework in Layer 3 can just delegate a task like send a summary email.
And Zapier just handles it.
Zapier executes it. This whole layer ensures the AI isn't just trapped in its own head. It can fetch, analyze, and, most importantly, execute.
And once that action is taken, we get to the final product. That brings us to Layer 5, the output layer.
The culmination of the whole process.
Yeah, this is where we see the final results.
And we have a fascinating detail here. The sources specify using an AI model called Cybersecurity for the final reasoning and generation steps.
Cybersecurity. That's a new one to me. It's not GPT-4.
Right. So while GPT-4 does the initial heavy lifting, Cybersecurity seems to be positioned to refine and structure the final results.
So why do that? Why use a separate model at the output stage instead of just letting GPT-4 generate the final document?
It's often a design choice for specialization. And honestly, cost optimization. GPT-4 is expensive. It might be overkill for just generating a highly structured document. Cybersecurity is likely a specialized model, optimized for formatting. The desired outputs confirm this. It's generating clean Google Docs, executing precise actions in Google Calendar.
So the final delivery is usable, not just a block of raw text.
Exactly. It automates a real business function.
Okay. We've covered the intelligence, the plan, the memory, the execution. But in a complex process like this, none of it works without management. We're in the engine room now, Layer 6.
The orchestration layer.
What's managing the workflow itself?
Orchestration is all about sequencing, flow control. If Layer 3 is the brain making the plan, Layer 6 is the project manager making sure Step A completes before Step B begins.
And we see LangChain again.
We do, alongside something called the Make Scenario Builder.
Make. That's interesting. How does that complement what LangChain is doing?
Well, Make, which used to be Integromat, is a visual automation platform, so you get the best of both worlds. LangChain handles the AI native logic, while Make provides this robust visual way for developers to define complex flows.
If this happens, do that.
If the sentiment is positive, then do A. If negative, then do B. Exactly. It allows for really structured, human-readable task management.
Which you need for high-stakes business processes.
Yeah.
Okay, now Layer 7, the execution layer. We talked about Layer 4 setting up the capability to act, but this layer emphasizes safe execution. What's the difference?
The distinction is crucial. It's all about isolation. Layer 4 establishes the API link. Layer 7 provides the secure sandbox where the action happens.
A sandbox.
If an agent is running code, say a script to analyze a data set, you cannot let that code run directly on your live, unprotected system.
Can you give us an example of the risk there?
Absolutely. Imagine the agent accidentally generates code that gets stuck in a loop or a script that tries to delete files.
Oh, that'd be bad.
Without Layer 7, that could crash your whole system. The source highlights Replit and Jupyter Notebooks here precisely because they provide these controlled, isolated environments. Safety and monitoring are paramount.
And that brings us to the final foundation, Layer 8, resource allocation and memory management. Maybe the least glamorous layer.
But maybe the most important for viability, yeah.
If we're talking about enterprise-scale agents, this has to work.
It absolutely does. This layer dictates whether the whole thing moves from a cool demo to a robust, always-on solution. Agentic tasks often have these bursty computational needs.
Meaning,
The foundational model in Layer 2 might need huge GPU resources for a few seconds to make a plan, then almost nothing while it waits for an API call in Layer 4.
so the system has to be agile. It has to dynamically assign and deallocate those resources.
Exactly. This layer manages the computational pool. It makes sure memory components like Pinecone are running efficiently. The key insight is that proper resource management is the only thing that makes the system scalable across multiple environments.
It's what lets you run 100 agents at once without the whole thing grinding to a halt.
Without efficient plumbing in Layer 8, you just create a massive bottleneck.
So what does this all mean? We've just taken a deep dive through 8 distinct but highly interconnected layers. It's a journey from that initial tally input to the GPT-4 interpretation, the line chain and AutoGPT planning, the secure replit execution, and finally, that Google Docs output.
Yeah.
It's clear that this kind of sophisticated automation isn't the product of just one big model. It's meticulous architectural layering.
And the key takeaway for you, the learner, is understanding that specialization. Every component is chosen for a specific purpose. Pinecone solves memory scalability. Agent graph structures decisions. The execution layer ensures safety.
It's a separation of concerns.
That's what it is. And that's what allows for rapid integration and robust automation. True agency comes from that.
And as you reflect on the future of autonomous systems, consider this. If the core ambition, the complexity of the task, is dictated by that agent's framework layer with bold tools like AutoGPT, how might the necessary constraints and the safety protocols of the execution layer, which relies on controlled sandboxes like Replit, ultimately set the hard ceiling on the speed and the risk that we allow these AI agents to take on?
It's a fascinating tension.
That balance between ambition and safe execution is the next deep dive for you to consider. Until next time, keep learning.